Alright, welcome back. In this video, we're looking at how to represent graphics in memory. It's important for us to know that a computer screen is made up of little dots called picture element, which is pixel. It is called picture element, which is in short called what? Pixels. So, so if you make each dot on and off, as we know, on and off, maybe if it's dark off, then on, you make it, you can build up a monochrome, which is black and white, a monochrome picture, a black and white picture. Also, the off and on can be represented using the binary 0 and 1. 0 for off, 1 for on. Here, the diagram we have on the board shows us a small picture graphic represented by a memory. So you could see this is a small graphic, and this is how it was represented. So the black and white allows 1 bit per pixel. So that's how that is. Now, so we also have various ways to look at that. Now let's look at possible questions that we might be facing. Possible questions that we might be facing include the following. Now let's go down a bit. We have a question before us. Calculate the storage requirements for a bitmap image which is 12 by 800 pixel. So they gave us an image, example 1. They're giving a bitmap image that is by what we have. The image is 12 by 800. So let us represent by a box. So we say we have 12 by 800 pixel with a bit depth of, so pixel is 12 by 800, that's the pixel. Then the bit depth, please note, the bit depth we are giving here is, we are giving of 16 bits. So they say give your answer in kilobytes. We are looking for a storage requirement for a bitmap image, and this image we are told is 1200 by 800 pixel. We're also told with a bit depth of 16 bits that we should leave our answer in KB, in kilobytes. Now, to do that, you look at what we have. So start by saying number of pixel. Number of pixel is equal to, the dimension we have is 1002 multiplied by 800. To multiply this by this, it's going to give us 9600. So it's going to give us 960,000 pixels. So number of pixels is 960,000. That's the first step. Then the next step is the storage capacity. You are going to multiply this value with the bit depth. So it's going to be 960,000 multiplied by 16 bits. We are giving bit depth of 16 bits. Recall, we are asked to leave our answer in KB. Two ways to do. Can choose to we have to leave our answer, if you recall, leave your answer in KB. So we can choose to do that immediately. Okay, let's convert first. You agree with me that 16 bits is presented as 2 bytes. We said 8 bits for 1 byte. So this can be said to be 960,000 multiplied by 2 bytes. If you agree with me with that. So if you have that, so whatever we have, it's going to give us 96 will give us, so 0, 0, 0, 0, 2 times 6 is 12, write 2, carry 1, 2 times 9, 18, 192. So this will give us, if you divide it, 960000 times 2, divide by the kilobyte. We are converting from byte to kilobyte. Converting from byte to kilobyte. So we divide by 1024. So if you expand this bracket, we will have 1875 KB as storage capacity. That's storage capacity for that. Another way the questions might come, the question might come in this dimension. They might not give you the pixel as we are giving. They might give you the dimension in inches. But when that is done, they must give you the resolution. Please note, if you are not giving the pixel of the image, but if you are giving the inches, the dimension in inches, that means the image, they must also give you the resolution. Please don't forget. If that is not, that means not correct. Now, example 2. Example 2 says, calculate the storage capacity of a bitmap image which is given by 8 by 4 inches. So we are given 8 by 4, 8 by 4, 8 by 4, 8 by 4 inches. That's what we were told. And we're told that, so 8 by 4 inches, and we're told that it has a resolution of 400 dot pi, that is dot pi, dot per pixel. All right, so we give a dot per inches. So that means for each of these inches, it has 400 embedded. Now recall, this is where so that we are giving 8 by 4 inches. Now they say for each of that inches, it is 400 inside one. That means we're going to multiply this 8 by 400 and multiply this 4 by 400 to get our pixel value. So, and we're also told that the bit depth, we have a bit depth of 24 bits. 24 bits, and we are asked to leave our answer this time around in MB. The first one was in kilobytes. We're leaving our answer in MB. If that is the case, let's go. So to solve that problem, you agree with me? So to solve the problem, that will be the storage capacity will now be, let's scroll down, let's draw our board a bit. So it will now be, so number of pixel, first of all, it is 8 by 400, 8 by 400 times 4 by 400. So that's that. So then for the storage capacity, I'm going to multiply this by the bit depth. So we have, so if we multiply this, you agree with me? You agree with me that if we multiply 8 by 400, 8 by 400, 8 times 400 will give us 32, multiplied by 4 by 400, 4 by 400, which is 16. So we have, so multiplying it by the bit depth, which is 24 bits. 24 bits, if you recall, 24 bits is the same thing as 3 bytes because 8 bits make 1 byte. So we can say 32 times 16 times 3 bytes. So whatever we have divided by 1024, 1024 2 times. Now we're converting from bytes to MB. So byte to MB, you have to convert from byte to kilobyte, then from kilobyte to byte. So what we have, we multiply this now, we have 16 times 32 times 3 will give us 15,36000. Now to convert it to leave your we have to leave our answer in MB, and the answer now is in bytes. So we're going to divide it by 1024. So we're going to divide this answer by 1024 again, then by 1024, moving from byte to kilobyte, kilobyte to megabyte. So equal to, so divided by 1024, you have 15,000. Divide it again by 1024, then we have 14.6. So we have 14.6 megabytes. So that's storage capacity required for that image. Thank you for viewing.